Hello and welcome. I'm Greg Brockman.
I'm Mark Chen. I lead research at OpenAI.
There are some models that feel like a qualitative step into the future. GPT-4 was one of those. Today is also going to be one of those days. We are going to be releasing two models, O3 and O4 Mini. These are the first models where top scientists tell us they produce legitimately good and useful novel ideas. We've seen great results in law. Talking to one of my coworkers yesterday, he said that O3 came up with a great idea for system architecture. It's like we haven't really seen anything like this. And the thing that's really amazing about these models is that they're not just models, they're really AI systems. We've trained them to use tools, which is not something that we had done with our previous reasoning models. They actually use these tools in their chain of thought as they're trying to solve a hard problem. For example, we've seen O3 use like 600 tool calls in a row trying to solve a really hard task. And we're going to be making these models incrementally available starting today, rolling out as quickly as we can in our API and ChatGPT. And one thing that's very near and dear to my heart is their ability in software engineering, and not just producing sort of one-off pieces of code, but really working in real code bases. I found that these models are actually better than I am at navigating through our OpenAI code base, which is really useful.
Definitely better than I am.
That ship has sailed for me a long time ago.
Yes. But it just helps you get so much more done. And so we're really excited to bring these to the world and see what you will all do with them.
The reason we're so excited about tool use is that it makes our reasoning models that much more useful and that much smarter. Just as you might use a calculator to solve a difficult math problem, or you might use a map app to navigate through unfamiliar streets, our models, when paired with the right tools, become that much more powerful. With that in mind, we combined our O-series reasoning models with our full suite of tools to achieve state-of-the-art results across a bunch of very hard benchmarks, including AMY, GPQA, Codeforces, and SWE-bench. And just to illustrate the power of tools, it can also give a lot of new functionality. For instance, we now can have the models think with images. And what that means is that the model can use Python to manipulate, crop, and transform images in service of the task that you want to do. This means that today you can upload complicated images. You can upload blurry, upside-down images, and the model will handle that without any problems. Now, these advancements are powered by continued algorithmic advances in our RL paradigm. We've continued to scale both train time scaling and test time scaling. And one thing that makes me so excited about these models is just 1 or 2 weeks ago, I saw that there was a new paper in condensed matter physics, right? And it used O3 Mini High to aid in the proof of a new unsolved theorem. And I really do believe that with this suite of models, O3 and O4 Mini, we're going to see more advances like that. So here we have two of our researchers. We have Eric and Brandon, and they're going to show us a demo.
Yep. Hi, I'm Brandon McKinsey. I work on multimodal reasoning at OpenAI.
Hi, I'm Eric Mitchell. I work on post-training along with lots of other folks for our O-series models.
All right, we're going to show you some things that O3 can do. I'll start with a science example. So this will be a physics poster. So I'm going to let O3 start thinking now so it can take its time. What I'm going to feed it is a poster of some physics internship that I did in 2015, so 10 years ago. And this poster, or the project, was supposed to estimate a quantity called the proton isovector scalar charge. It's a beyond the standard model of particle physics quantity that tells you how short-range interactions, how strong they are. And what you'll see is that the model, O3, is zooming in. It's kind of like browsing around. Here, I'll zoom out just to get a little bit better view. And it is kind of looking for the right quantities for the question I asked it, which is to basically find this result that I had and compare it to recent literature. But there's a small twist. The result actually isn't in the poster, and that's because I didn't have it yet. Although it's in the final paper for this project, it's not in this poster, and I'm actually asking O3 to do the rest of the project for me, essentially.
He uses the same trick at OpenAI.
Yeah. It's true. Great. So it found the plot that I wanted it to find. It's supposed to figure out that it needs to find the slope of this plot, extrapolate down to a specific like physical quark mass, and then like grab that quantity, and then actually apply another quantity to normalize that value. And I think it is already kind of figured out that this is what it should do, but it is just spending a little bit more time exploring the image. Okay, it's good. It's now going to browse the web for recent results.
Yeah, why is it searching the web?
Well, I think I actually, did I ask it? I said, oh yeah, find any recent findings that have like updated estimates. So now it's like just looking at like the literature and seeing what people have done and how it compares to the result that, well, that it thinks that I eventually arrived at.
And how long do you think it would take you to do this task?
Quite a long time. Yeah, so I mean, it took me a long time just to remember what my poster even meant in the first place. And I also didn't even realize that the result wasn't there when I first asked it this question. It actually told me that. Which was nice. So many days just for me to even like onboard myself back to my project, and then a few days more probably to actually like search through the literature. And I mean, it must have just read at least like 10 different papers in a few seconds for me. So that's a huge time savings. Great. So it has summarized my result here. And these numbers look correct to me. So it's figured out like there's like this unnormalized value that it's like estimated by extrapolating. And that when you multiply by this specific constant, that it will renormalize it. And it says, okay, you would have ended up with this, which is somewhat close. I think it ended up around like 1.2 in my paper. And then it compares with the actual literature here. So there's a few different estimates, and looks a little close, I'd say. So let's see what it says. It says my bear value looks high because it needs to be renormalized. That's correct. After you multiply by that, you get something that's more consistent with the state-of-the-art results. That's great. But it says my precision isn't as good as the state-of-the-art, which is fine. It was an internship.
Not bad for an internship.
Exactly. So
We'll allow it.
I'll take it. So it seems like it's still a reasonable estimate that maybe has a little bit more uncertainty than recent results, which is great. So the field has made progress, which is awesome to see.
That's such a cool example.
That's super cool.
Cool. Now I'll hand it off to Eric for his example.
Cool. Yeah, it's tough to go after a demo like that, but I'm gonna show another aspect of O3's capabilities that I also think is super cool. As Mark and Greg have said, one of the cool things about these models is they can use all of the tools that we have available in ChatGPT. So I just turned on memory for this model, so the model knows a few things about me, and I'll get this one started as well. And so as people have said, models are super smart, which is really, really great, and they can help us with even cutting edge research in all sorts of fields. But even if you're not literally a researcher in particle physics, this new intelligence and these sort of more agentic kind of abilities to use tools is still useful, and it can still be very valuable for you as well. And so what I've asked O3 here is just based on what you know about me, so it has access to memories now, read the news and teach me something that I probably didn't know, but that I would find really cool in particular. And so this is going to involve knowing something about me, but also doing some of this agentic thinking and tool use to look up some potentially relevant interesting things. And here I've also asked it to actually plot some data or information that I could put in a blog post if I wanted to tell people about this cool new fact. And so what it's done here is some of my interests are scuba diving and playing music. And so it's sort of combined these interests, and it's actually found this line of research that was actually kind of mind-blowing to me, which I didn't know about until I actually was working on this demo, where researchers actually make recordings of healthy coral reefs, and then they literally play back those recordings underwater with an underwater speaker, and that actually accelerates the settlement of new coral and even fish to sort of heal that coral reef and have it regenerate more quickly. And so this is like an actual line of research in coral reef preservation, and it was a very cool sort of synthesis of both underwater exploration and also music. And so here we have a nice blog post. So the model is sort of smoothly both browsing. It's using advanced data analysis to show and plot some data for me. It's using Canvas to generate a blog post. and it's summarizing at the end with some citations, what it found and where it got those results from. So again, these models are super, super smart, which is awesome, and I'm really, really excited about it. And I think this new intelligence and sort of ability to use tools will be useful whether you are literally at the frontiers of some scientific field, or you are integrating this model in your everyday workflows.
I wonder if you can maybe play sound for a physicist too, and improve their results.
Yeah, what should we play at work?
Yeah,
we should
the
ask
sound
the
of a
model.
healthy
Healthy physicist? What does a healthy physicist sound like, Brandon?
I'll look into that. I'll ask O3.
Cool. Thank you guys both for showing these really compelling demos. Next, we'll have Wenda and we'll have Ananya come on and talk a little bit about how the models are trained and also what the evals are like.
Great.
Thanks a lot.
Thanks.
Thank you both.
Man, yeah, super incredible.
It really
just
is.
Knowledge work, and also, even if you're just doing something that's highly personalized, it's
Yes.
very useful.
And to me, the magic is that under the hood, it's still just next token prediction.
Yeah,
Right?
yeah.
It's just a model that's just thinking about what should come next.
With sprinkles of RL.
Exactly. We've changed the objective, we trained where the data come from, and now we're able to really hook it up to the world.
Hi, I'm Wenda. I'm a researcher at OpenAI, and I work on scaling RL systems.
I'm Ananya. I'm a researcher at OpenAI, and I worked on some of the algorithms for these models. So we wanted to start out by showing some results on standard benchmarks for these models in math, coding, and science. So in these plots, the dark yellow bars are the new set of models, and the light yellow bars are the old set of models. And we see a pretty substantial boost. So on Amy, which is a hard math contest, O4 Mini gets 99% accuracy with tools, pretty much saturating the eval. On code forces, these models get over 2,700, which place them in the top 200 contestants in the world. And GPQA is a set of hard PhD level questions, and O3 gets over 83%, which is pretty incredible.
It's pretty good.
We want to go beyond the eval numbers, which are incredible, and show you a little bit how our model uses tools in order to solve those problems. So here, for example, we have a problem from the Amy math contest. And the problem here is asking you to look at this grid of 2x2 squares and count the number of combinations of coloring that verify some constraint. And let's see how the model does it.
Yeah, so the way the model thinks is really cool. So it starts out by producing a brute force program and then runs it using a Python interpreter. And it gets the right answer, which is 82. But this is messy, right? It's pretty inelegant. And the model recognizes that and then simplifies its solution and comes up with a smarter way of doing things. It then also double checks its answer to increase its reliability, which is kind of neat. Now, these models are not just trained to output the right answer, they're also trained to be useful. So in this case, it now gives the solution in words to explain it to a human. What I found really cool here was we didn't train the model to use certain strategies directly. We didn't say, simplify your solution or double check. It just organically learns to do these things, which is pretty incredible.
Yeah, it's super cool that it comes up with essentially the intended solution here that a human would be able to do, whereas the first brute force solution, of course, you would never have time to do that in the actual contest. So beyond math science, we also want to share, a lot of you, I know, use these models for coding, and we want to share some practical coding benchmarks. So on SweDancer, SweBench, and Ada Polyglot, we achieve state-of-the-art results with the model when it's allowed to use tools end-to-end without any harness or any specific things like this. And to illustrate a bit more, I want to share a SweBench example with all of you. So for this example, I'm running it with O3 High in the API with access to the container tool. Unfortunately, it will take us a couple more weeks to put the final polish on a tool running in the API. And so you won't be able to run this today, but I want to share this because I'm so excited about how the model is using the tool. So the problem the model is asked to tackle is the following. It's concerning a bug in this package called SymPy, which is a Python package which is used to manipulate symbolic mathematics. And I'm prompting the model with the question, and I'm also giving the model access to a container, which is a virtual machine, with the SymPy repository preloaded. So the model has access to a shell with all the code already there, and the model will have to figure out the bug. So the cool thing is that the model starts by just double checking what I'm saying and seeing whether it observes the same thing. Like I would do when someone bugs me about something, I'm just going to check, is it actually a problem? And the model does see, oh yeah, it seems to print out max of 2x with the round brackets and the square brackets.
I bug Wendell a lot, and he does that.
And he always has good questions, though. So, yeah. And then after this, just to double check, it will check that sign is now rendering correctly. So this is the square brackets, it's the intended behavior, and it's the bug we're trying to fix essentially. And so the model will go around and browse the code and try to kind of get the lay of the land of the repository. And to do this, it just uses common terminal tools that Ananya or me might use in our day-to-day work. So like it lists the files, it opens the file with sed, and it will kind of print out the relevant files and try to find what it's looking for. After some browsing, eventually the model figures out that maybe it can check this thing called the MRO, which is a Python construct that tells you about the inheritance of the class. And then based on the previous knowledge that the model has acquired, it notices that something is wrong, and this class does not inherit from function, but from application. And so the model browses around it a bit more, and eventually figures out that there's a good solution here. We can change this file to implement this. So it uses apply patch, applies a patch, and then hopefully this is the right solution. Finally, to confirm this, the model runs a unit test, just like any good engineer would, to double check that it has gotten the right thing, and it sees that indeed now it's printing with the square brackets. So this was a really cool route, and it's really cool to see the model kind of arranging this all by its own. This route was actually on the shorter side of Sweetbunch, and there were about 22 interactions and 16,000 tokens.
In some cases, the model uses more than 100 container interactions, and on average, it uses 37. So it's pretty cool that it can do these long rollouts with so many container interactions and get the right answer.
Yeah, doing a rollout that long with reliability is not trivial at all.
It's really hard. Yeah. We also wanted to show some numbers for standard multimodal benchmarks. And these numbers are just crazy on MMMU, MathVista, Charchive, and VStar. So we really hope these models are useful for your multimodal tasks as well.
Yeah, this is really, applying the reasoning paradigm to multimodal, which was previously not possible. And now, as Brandon demoed, the model is able to manipulate the image directly in the chain of thought, and that leads to a huge increase in capability for multimodal. Yeah, finally, I want to share another few evals that we run externally. So Humanity Task Exam, as you can see, our O3 model is able to get close to deep research. But O3 will run much faster, and of course, much fewer rate limits in ChatGPT if you are using it in ChatGPT. So we think it's a very cool model if you do not need a full report like what deep research produces, but instead are still interested in some agentic behavior to help you grab information.
So in these plots, we show the performance on the y-axis against the estimated inference cost on the x-axis. And we see that O4 mini is quite a bit better than O3 mini for any given inference cost.
Additionally, one thing that is not shown here is that O4 mini is a multimodal model, unlike O3 mini. So if you need a small and fast multimodal reasoning model, I'm very excited for you guys to try out O4 mini.
The results for O3 are even more stark. You can see that it can get the same performance with way less inference cost. And if you're willing to pay the same amount as O1, then you get a much higher score. So these are pretty amazing models.
Yeah, and this is why we're going to replace the O1 models with the new ones.
Yes. Yep. One thing we should mention quickly is that due to of the optimizations we've done to make the reasoning more cost efficient, and also the model more useful in general, it is not as benchmark optimized as the numbers we shared for the 12 days of Christmas. So there might be some small disparities up and down. Generally, it's gone up in multimodal, for example. We still think that this is a much better model because it's much more optimized for real-world use cases, and you won't have to wait as long when you're asking for an answer, which is a real thing with these reasoning models.
People are impatient.
I am impatient.
Yeah. So these models are a result of a lot of rigorous science, ingenuity, and craftsmanship. And we put in more than 10 times the training compute of O1 to produce O3. And it was a lot of hard work by lots and lots of people, but the end result was really beautiful to see. As we scaled up compute on the x-axis, the performance on evals like Amy just kept going up.
Yeah, so this is really us, going and retracing our steps through the GPT series, right, which was this kind of predictable scaling and pre-training. And now the goal is really we're trying to get through this scaling in RL and showing that as we put in more RL compute, we're also able to get commensurate gains. Yeah.
So what will O4 look like?
Yeah, I think if we just draw the line, 110% on each.
You heard it here first.
Great. We're so excited for you to try out the model.
Thank you. So we've shown you the models. but we have one more special surprise. Here to show that to you are Fuad and Michael.
Hi, I'm Fuad on the Agents Research team.
I'm Michael, also in Agents Research.
You know, I remember seeing a couple years ago the Codex demo, and it's just so wild to see how far we've come with these new sweet bench numbers.
Yeah, that model in that demo was kind of the first time that anyone had seen what is now called vibe coding. What a great term! I wish we had it at the time. And we called that model Codex because it really captures the fact that code is so integral to what we were trying to train the model to do. And so today, what we're going to show you is the continuation of the Codex legacy. We're going to be releasing a series of applications that we think will define what the future of programming looks like. And today, we're starting with the first one.
Great, yeah. Today, we're excited to share Codex CLI. It's a lightweight interface to connect our models to our users and their computers. You can think of it like a reference implementation for how to safely deploy code executing agents where you need them. It's built on top of public APIs like the Responses API, taking advantage of new features like chain of thought summaries in that API, and our latest models like O3 and O4 Mini with multimodal reasoning capabilities. But enough talk, let's actually see a demo. Michael?
Awesome. So I went online to see what people had built with O3 Mini. And so I found this cool image to ASCII generator. The author said that they built it with O3, but I'm pretty sure they meant O3 Mini. So
Unless they were time traveling.
yeah, right. And so, so I thought today we would re-implement this using Codex and O4 Mini just from the post. And so I'll start out actually, but just by taking a screenshot. And I'll take the screenshot and I'll drag it to my terminal. And so I'll give it to Codex. And so as you can see, I've passed it in using the image flag. And so Codex will start using that multimodal reasoning that we saw earlier from O4 Mini.
And one amazing thing about using these models directly on your computers, you can take any file, any code base that you're working in, just go and grab that, put it into Codex, and here we can actually see some of that chain of thought that we were talking about earlier. It's asking for some clarifying questions, it's thinking about things, and then it actually looked at the image and even suggested a few things that we might want to do with it. What did you have in mind?
I thought we would just re-implement what we saw in the post.
Yeah, but since we're live, maybe we'll make it a little bit more fun. Let's add the web camera API, and just for the folks watching on the live stream, maybe let's make sure we keep it in the 16 by 9. I don't want some really small little video, but do you want to go and try that?
That sounds bold, but I like it. All right, so now it's going.
So while it's thinking, I think one of the amazing things about Codex is that you can actually see it both think and also run the tools directly on your machine. So like what they mentioned earlier with function calling and the API, you can actually expose any of the existing functions that you would use, and in the future we'll have the full suite of tools that you'll be able to use in the API. And while it's thinking, do you want to maybe talk a little bit about how it actually runs the commands? We can start to see it actually running some commands now.
Yeah, so by default, Codex runs in what we call suggest mode. And so as it's running, it suggests commands to edit or commands to run or files to edit, and you get to approve each one. But that can get a bit tedious. And so for the sake of the demo, I ran it in what we call full auto mode.
Yeah, and a little bit about full auto mode. It's a mode where you can allow the agent to go off and do its work, but still stay safe and secure. So it's able to run commands network disabled and limit the edits that it makes to the directory that you ran it in. So it gives you the peace of mind of actually having something that can go off and do things, but without the risks that come with just letting it run whatever command it wants. And it looks like it's pretty fast, so it's already done.
It's already done.
So you want to go and pull it up?
Yeah, so it said it created this ASCII HTML file. So let's go pull that up. Got to give it some permissions.
Always need some permissions.
And let's see.
Oh, that's so sick. Oh,
Nice.
Oh, it's sick. It even has a little width slider.
Let's see.
Not quite what I thought a width slider would do.
Oh, but it's low res us.
I do love the low res version. Greg, you want to say hi?
There we go.
Hi.
Nice.
Amazing. So as you can see, it's so fun to use Codex. We've been using Codex to actually build Codex, and we're incredibly excited to see what you do with it now that it's fully available. And not only is the tool available, but we're also open sourcing all the code. So you can go up, as of a few minutes ago, to our GitHub, OpenAI/Codex, and go check it out. You can even use Codex to explain the repo to you. We're incredibly excited to see what you do. Alongside Codex CLI, we're also announcing a $1 million open source initiative to support projects with API credits using our latest models, using Codex CLI to accelerate the frontier of open source. We'll have a link in our research blog post for more information, but with that, I'm going to hand it back over to Mark.
Thank you both.
Yeah. Thank you both so much. I want to talk a little bit more about ChatGPT availability. So starting today, if you are a Pro Plus Team subscriber, we're going to start rolling out access to O3, O4 Mini, and O4 Mini High. And as you saw from Ananya's post, these are strictly better than the previous generation of models, so they will be replacing the O1 and O3 Mini series of models that we had before. You're going to have to wait a week if you are enterprise or EDU. And if you use O1 Pro today and you love it, we are going to roll out O3 Pro, but it will take us some time to make sure all of the last remaining features are tied up.
We are also releasing these models in the API. In upcoming weeks, we will release tool usage in the API as well. So that will be really exciting to see what people do with them. These models, huge amount of work making them available from the entire team. And so it's been a real labor of love to bring these to the world. And we really view them as a major step forward in our mission of bringing AGI to benefit all of humanity. And so they're very useful for scientific applications, but we also think that they will be useful in your daily life. And so please use them, explore what they're capable of, and we're just so excited to see what you'll do with them. Thank you.
Thank you to the team.